It's okay. So you got it going? So I'm going to click, it was number 13, and it's confusing because it says SAH SO69 on the kiln. It also says 13. For whatever reason, sometimes one of them shows up and not the other. So you just want to make sure you're on the right one. And once you're on the right one, it's going to come up with the desktop of that kiln. And I always sort of make myself check and make sure it's actually the right kiln. And Benj was really thoughtful and put pictures on the desktop of each of those computers of the actual kiln. So we should make sure that there's a 13 on the top of this when it shows up. And there will be, because I clicked the right one. But so we know.
Awesome.
Okay, so the next thing you do is you click this little icon right here, which says Guile Kilns. And then it's going to bring up the program. They're slow. Maybe it's going to do it. Come on, buddy, you can do it. Yes. And there's a lot of waiting for this little green thing to go across. And you can already see it knows the temperature in there the same as it was when we just checked. And so really what you want to do when you get in here, you have to open a program, and there'll be many choices. Eventually you can make your own that you like. And ultimately you wind up sending that program from here to the kiln and then pushing run ramp soak when it's ready. And then you have to go in there and push the button that actually turns on the burners. While it's cruising over here, I'll say a couple things about that. The kiln system is pretty it takes a minute to kick in, so especially with a big thing like you have. I don't think it would even matter if the door was shut all the way, but when we push that burner button on, I like to open the door until I see the burners actually react to the program. Because what it'll do first is turn them on full blast. Actually, most of the time it does that. Sometimes it seems to know and it starts them small. I don't really understand why it does it sometimes and not other times. But what you don't want to have happen within any of this is for your work to get too hot too fast. So the idea, for me at least, is I open the door when those burners turn on full blast so that it's not quite as hot in there in that moment. And then when I see the burners start to sort of die down, then I feel comfortable closing the door. So, communication established successfully. Okay. So, now once we're here, we can go to view the progress. Open ramp soak programs. Usually I have to click around on everything before I figure that out, but that is the right thing to click. Okay, so, and this is what the program screen looks like. This program might be okay, but from my perspective, I like to use my own program. And I think it will be fine for what you're going to do. So, sorry, I didn't tell you open program files right there. Come on. And it saves all these things in order of when they're created. So I can see Andy updated slow bisque from June 13th. Let's see. There's also one of these Guile firing programs is. One of these is local to this computer, the other is networked between all of them, and I'm never quite sure which one is which, so I click them until I get to this one that has pizza in it and all these other things. And I go to bisque, and then I see there's all of these options. This is the one I just did the other day, October 3rd, class slow bisque, updated slow. This one is probably slower. So let's take a look. So I'm going to open that program, and right away it's going to load it. Maybe. Doesn't seem like it did load it. Desktop, control, bisque. accepted. Slow disk. Open. Yes. Okay. So, what this program is showing you is that it's gonna, and I like to usually like have when I make these programs, I'll bring up like the calculator so I can actually figure out exactly how fast it's going. It's gonna take 5 hours to get to 600 degrees, and you're already at almost 300 degrees, so that's a long time. It's like 50 degrees an hour or something. In sort of kiln language, I think about like 50 degrees an hour being really slow. 200 degrees an hour is pretty fast. And 300 degrees an hour is like kind of insane. Yeah. So somewhere within that range, something that big, I wouldn't ever go any faster than like 150 degrees per hour at any point in the process. And this program is going to work that way. So it's going to go 50 degrees an hour essentially to 600, and then it's going to take an extra, it's about the same, but to get to 700, because between 6 and 700 degrees is when the chemical water molecule leaves the mixture inside your work, and so there's a slight expansion or change in size in that moment. So I go a little slower then. 4 hours to 1,000 degrees is just under 100 degrees an hour. I like to go super slow through quartz inversion, which happens at 1065, and this is when the quartz in the clay goes through a phase shift, and there's also a slight percentage expansion in size. That's the most volatile point in the firing, so we actually slow down here to 50 degrees per hour. So by taking 3 hours to go from 1,000 to 1150. Once you're over 1150, and you can see we soaked and I soaked actually for an hour here too, just to make sure that it was really at 1,000. And I'm going to soak at 1150 for an hour to make sure that I'm really that everything in there is past course inversion. Then I can go faster, 3.5 hours to 1,700, and that's what 550 degrees. So it's more like 125 degrees an hour or something like that. Hold it there for 30 minutes to make sure it's really 1,700 degrees, and then an hour and a half to the final temperature to 1865. And the reason for slowing down at the end is because you want it to be a true cone 06. If you go, like the cones are rated to bend at 108 degrees per hour. So if you go 200 degrees an hour, cone 06 is not the same temperature for your work. Or if you go 50 degrees an hour, I mean, the time and temperature have to be at the right ratio to equal what we think of as cone 6. Does that make sense? Yeah. Okay. So anyway, that's the reasoning for all of that. So, okay. Is this the program you want to use?
Yeah.
Okay. So then we click send program to controllers, and this takes a minute. And essentially the only thing after this to do is to click run ramp soak, and then go in there and push the button.
Okay.
So it's a bit cumbersome waiting for it to communicate. Otherwise, it allows you a ton of control over the firing. If you were firing like glaze and you wanted to reduce or change the atmosphere at all, you would do that over here in this atmosphere section. And those three having nothing in them, just doesn't matter. I don't know why I didn't put a 0 there, but it just didn't. If
it just goes like 1, 2.
Yeah, so each one of these is a segment, and the times have to make sense. They have to, like, this first segment time has to be the same as this, and so even if you're not doing anything over here, you have to make the times line up. If you did want to reduce, it would be probably around line 5 here, around 1,700 degrees is normally when you would start. Actually, I think the atmosphere controllers kick in at maybe 1,200 degrees. You could do an extra low reduction if you needed to. But you would put a value in this box that you would get out of the manual for the kilns. And it has a chart that says light reduction, medium reduction, heavy reduction at these temperatures equals these percentages. And so you kind of have to find, like, oh, it's 1,700 degrees. I want medium reduction, so that equals 12. And it'll give you a range. It'll be like 11 through 15 is medium reduction. That might not be quite the right number. But anyway, you put that number right in there out of the chart. And so you could say I wanted like light reduction starting at 1150 up to medium reduction at 1700 and heavy reduction at 1865. You could control all that really precisely and it would do it.
Right. Are the manuals somewhere?
Yeah, there's a manual sitting on the wall in the back in the kiln room, like the blue glass wall that's against the outside.
Right.
There's also, there might be more than that in there. There's about 6 of them in Ben's office too. And I actually think that the page that has the reduction table on it is on the iowaceramics.com website. Maybe. I can't remember if, I think the whole manual is on there in a PDF form.
Oh, wow.
With like the passwords crossed out so people can't just get in from anywhere.
Right.
But yes, that it's accessible if needed. And actually, I should look at it. If that table isn't there, I should put it on there because it'd be helpful to just be able to look that up if you can't find the book. When it finishes this, it's going to say success or something like that, and then we'll know that we're good. Most of these programs are like a little bit cumbersome like this, but ultimately it's much easier to spend 15 minutes doing this than it is to drive back at 2 in the morning and 4 in the morning to turn the burner up and adjust the damper, which is what I would normally do. I would prefer to sleep and let the kiln, let the computer run the kiln.
So in the past, you've had to do each step.
Yeah. So normally, like if you don't have a gas kiln with a computer on it, which most individuals in the world don't.
Right.
This is the downside of this because it's like we're teaching people to do this, but odds are this is the only time in their life they're going to have this. You don't have anywhere near this precise of control over the firing. You can control the reduction, you can control the heat rise, but you're normally using visual clues like how it looks in the kiln, how long the flame sticks up above the burner when you look in the spy hole and look at it, or how it smells inside the kiln. And I really value that type of interaction with kilns. Like that's how I learned, and I feel like that's the downside to this, is that we could disconnect one of them, but I also know that if we do that, nobody will use it. So it's kind of like we've thought about, and I think eventually we'll do this, maybe doing like disconnecting one of them and doing like a firing workshop for like a week or 2 or something, just to kind of like
that would be valuable.
Give people the experience of it, but then switching it back. I think it is really important. And you ultimately would, you would just go slow in the beginning and you would watch the parameter. And what I do when I look at the parameters, I count how long it takes to jump a degree, and then I do the math, and like if it takes a minute to go 1 degree on average, then I know that it's going 60 degrees per hour. If it takes 2 minutes, then it's 30 degrees per hour. If it takes half a minute, so you can kind of ballpark off of that. But it doesn't stay consistent, and oftentimes like it'll change when you're gone, so or you turn it up and it jumps really fast for a while and then it sort of